Hey guys, welcome back. Hope you had a great weekend. Hope you had a chance to kind of recharge a little bit, um, keeping up on your classes, and we got 2 more days today and tomorrow until spring break. So let's hang in there. Today's notes are a little bit confusing, and actually, if you want to pause right now to go get your book, we're going to be on page 25 in your Unit 5 book. Okay. I'll also post a blank version of these in case you don't have your book with you. So, all right. So today's notes are on transformation notation. It's 512. So transformation notation. Notation is the way that we write things. So we're going to talk about. There's a lot of letters, a lot of variables that we're going to use today. The good thing is that you have a video, so you can always go back and rewatch it, and then I'll have the key for these posted. But you got to make sure that you're doing the practice so that you get used to this, because the more you get used to it, the easier it's going to be. So first off, we have a 0.53. Okay, this is our pre-image. This point that we're given is our pre-image. It's the figure before anything's done to it, before any transformations are done. If I just have this capital T by itself, and I'll show you where we add some numbers after, but if I just have a T by itself, that's just generally a transformation. It's a change to the pre-image. This here is what's happening to our pre-image. So this is the result, or the image. So we can see here, my original X is going to change by adding 2. The original Y will change by adding 2. Well, that's actually a translation, right? I'm shifting what right to and up to. So this one happens to be a translation, but let's kind of walk through these. So identify the given point, 5, 3. Identify the transformation. Well, the transformation, which we're calling T, is this, X plus 2, Y plus 2. We said that will go right to, let's say shift, right to, actually, you know what, let me use the correct vocabulary here. Translate. Right to and up to. It's the same as a shift. Calculate the new coordinates. Okay, so this transformation that we're calling T on a variable x comma y, well, I don't need a variable anymore because I have the actual point, right? It's 5, 3. So this transformation on the point 5, 3 is going to result in 5 plus 2, comma 3 plus 2. Which gets us 7, 5. So 5, 3 is the pre-image. Here's the transformation. Here's our image. Okay, example 2. We have a triangle now, so not just one point. So triangle ABC with the following coordinates, and I have a transformation T, and it results in x negative y. So what this means is x is going to stay the same, y is going to be the opposite. It's going to turn negative. So what are the new coordinates of the vertices of the transformation of ABC? So this means transformation of triangle ABC. So basically, what happens after the transformation is made? Well, let's see. I have, I don't need to really sketch anything, but I know that A prime is going to be, instead of 5, 2, it's going to be 5, negative 2. B prime is going to be 3, negative 5. And then C prime is going to be 2, negative 2. So I guess the correct way would be, okay, I'm going to transform point A right? It's going to be x negative y, right? So I could do that for the other 2 points as well. So let's take a look over here. Let's plot these new points. So 5, negative 2, 3, negative 5, and 2, negative 2. So A prime, B prime, and C prime. So the other part is, what kind of transformation is this? Well, we can tell that this is a reflection over the x-axis. Here's how we write that with the notation. Reflection is lowercase r over the x-axis. Okay, so this is kind of the general. For any point, I'm just reflecting over the x-axis. And it's going to equal x negative y. Okay, example 3. Given the transformation of a translation t5 negative 3. Okay, so here's what this means. t5 negative 3. This means translate. The 5 is the horizontal movement, so positive 5 is right, 5. The second number is vertical, so in the negative direction 3 units. That's going to be down 3. So given the transformation, which I should say, which is a translation t5 negative 3, and the points P and Q, show that the transformation, let me rewrite this, show that the translation is isometric by calculating the distances or length of PQ and P prime, Q prime. So this probably makes it easier. Given the translation of these points, show that the translation is isometric. All right, first things first, let's plot these. So I have P and Q over here, and I connected them so it's a line segment. Now let's actually translate and show those new coordinates. So I'm going to go each of these points 5 right, 3 down. So P is going to be become P prime. Here's Q prime. That was bad. Okay, so let's find the distance of each of these. So PQ is how many units long? We could just count boxes here, right? That's 6 units. And P prime, Q prime, also 6 units. So here's what this means. Isometric. That means the free image is congruent, or congruent symbol, to the image, meaning it's the same size, same shape, same size. Well, we see that's the case. So that's how we prove that. In general, any translation is always going to be isometric because you're not changing the shape. You're literally just copy and pasting, shifting it in one of our 4 directions, up, down, left, right. Okay, example 4. So here's my translation. So let's see, this is going left 6 up 2, right? That t negative 6, 2. Of any point xy results in x minus 6, y plus 2. State the translation that would yield the identity transformation. So the identity transformation, call it capital I, And all this means is the image is congruent. We actually shouldn't even say congruent. We should say equal to the pre-image. It's exactly the same. Not only is it congruent, it's in the exact same position. So it's as if no transformation took place. Okay, so if you have an identity transformation, you could not witness the transformation, look at the image and the pre-image and say, oh, well, nothing happened. Okay, well, let's pick any point. I'm going to pick 1, 1. All right, we plotted 1, 1 over here. Let's perform this translation. So x minus 6, y plus 2. So x minus 6, y plus 2. So this is going to give me 1 minus 6, 1 plus 2, which will be negative 5, 3. Okay, so find a new translation. Get back to the original point 1, 1. So how do I take this point in blue and get it back to the point in red? So I would have to go right 6, down 2. Okay, so the translation is going to be t, right 6 would be positive 6, down 2 would be negative 2. Right, there's the simple translation. So the identity transformation up here, this 6 and negative 2 is the h and k here. So could say the identity is going to be a translation 6, negative 2, negative 6, 2 over point x, y. Here's the other thing we didn't talk about. This just means we have 2 different translations. Here's the original one. Here's the one that I found. We always work inside out, so that means that this here is the first transformation, and this one is the second transformation. We work from the inside out, okay? Okay, so in the minute and a half I have left, I want to talk about number 5 here. You guys do not have this sheet, so I'll put a blank one online for you. But you don't have this. This is from a different book, but these are really similar to the homework problems you're going to have. So most of these I think you can get just from looking at the answer key here. But notice I changed number 6, and that was kind of extra. For number 5, if the transformation t is isometric and DAB equals 4, what is DTAB? Here's what this means. You have some transformation t. I don't know what it's going to be, but it's a transformation and it's isometric, meaning that the isometric, it's going to be congruent, right? The image and the pre-image are isometric. This lowercase d means the distance or the length, right? So the length of AB equals 4. That's kind of like what that whole thing means. Over here, we're saying what's going to be the length of AB after the transformation. So this means the length of A prime B prime. Well, we know that that's isometric, so it's also going to be 4. That's all we're saying there. All right, guys, I'll be online at 12:30. Thanks for hanging in there.